magnetism, North Pole, South Pole, a bar magnet, they're not shifting and staying on opposite sides of the planet. One is going over towards Siberia. Follow that, keep following that, and you hit the Indian Ocean, right? South magnetic pole has left Antarctica and is heading towards the Indian Ocean. The magnetic poles are on a collision course for the Bay of Bengal, which is the northeastern Indian Ocean, in between the subcontinent of India and where the Sunda megathrust, the 2004 Christmas tsunami, happened in Indonesia. It's actually right where they're supposed to meet. It's right where that plane just vanished a couple of years ago into thin air. A lot of strange magnetic anomalies around the exact spot where the magnetic poles are on a collision course right now. And what's interesting is the exact opposite side of the planet is the South Atlantic anomaly.
Right.
This is where I do start to break from mainstream science a little bit. They want to say, oh, there must be something happening at the core mantle boundary that is causing the South Atlantic anomaly. I want to be clear. They don't have the first clue what is happening down at the center of the Earth. It is guesswork, sometimes very educated guesswork. At the end of the day, they don't really know.
Yeah, that's for sure.
They actually just came out with a paper a couple of days ago talking about how, carbon is the reason why we have a solid versus a liquid core, why one is solid and one is liquid. It's the carbon that caused the solid one to solidify. Brand new discovery just a couple of days ago. Is it true? I have absolutely no idea, and frankly, neither do they. But the point is, they keep coming up with things. The science is changing too quickly for somebody to say, this is the way it is. And especially for a place that we've never been. We know more about Mars than the bottom of the ocean. We know even less about the center of the Earth.
Right. That's for sure. Yeah.
But if you've got a point on the planet and the magnetic poles are moving away from it, you've got a refrigerator magnet, you pull it a millimeter away and let go, it'll probably stick to the fridge. 2 millimeters, it might still get sucked in and stick to the fridge. You pull it a foot away, it's hitting the floor when you let it go. Magnetism drops off at 1 over distance cubed. And so the further away you get from the magnet, the less the magnetic field. The South Atlantic anomaly, the weakest magnetic point on the planet, is the exact spot away from which both magnetic poles are moving. It's the simplest, easiest, and almost certainly the correct answer for why that exists.
Right. So what you're saying is the South Atlantic anomaly is a point of weakness in the southern hemisphere of the magnetic field, and both the north magnetic pole and the south magnetic pole are racing towards the exact same spot. They're currently going, the north is definitely racing, the south is moving towards that same spot that's at the exact opposite position on the globe of the South Atlantic anomaly.
Exactly.
Yeah. And so what is the implication of that, or what does that mean? Like, what's actually happening? Once the north and the south pole get to the same point and they meet, what is that? Is that the new north and south pole? Does the South Atlantic anomaly become the southern?
It's very likely that one of the magnetic poles will have its home there in the Bay of Bengal, east of the Indian subcontinent, and the other one will sort of take the natural polar field setup that Earth has, that most spinning objects have, and sort of pop out the other side of the planet. Maybe that's directly in the South Atlantic anomaly, maybe that's in Brazil, maybe that's off the coast of Ecuador, somewhere in that general area.
Okay. And so then, how long does that, so to get from where we are today to that point, again, you're saying 10 to 25 years to where that is the reality. And then how long does that kind of maintain itself, and then what happens next?
Well, the magnetic poles should probably stay there for about 6,000 years.
Okay.
But it's what happens all very quickly leading up to that, and then when that event happens, that is why anybody should care. If all this means is, we've got to learn how to use compasses differently, or we've got to redo the GPS system, for most of us, who cares?
Right.
Okay, let the nerds of the government figure that out, right? I don't care. Unfortunately, it's not so easy. There are several things that happen when you get the magnetic field, the magnetic shield of the planet changing in this way. And so maybe we should go to that for a second.
Okay.
So, why is it important, the magnetic field of Earth? Solar flares, solar wind, cosmic rays, supernova blasts, gamma ray bursts, all that scary stuff from space. It's not like a shield in a Spartan warrior would have. It's a shield of magnetism, and it shrouds our entire planet. And because most of this dangerous stuff from space, with the exception of asteroids, all of the scary stuff from space is electromagnetic radiation, either light, X-rays, ultraviolet, gamma rays, or it's electromagnetic radiation particles, protons, electrons, ions, things like that. This magnetic shield does a phenomenal job of blocking it out, and our very thick atmosphere absorbs almost all of what it can't block out. The problem is when the magnetic field begins to change, and specifically weaken as it is right now, the number one thing it does is let in more of that particle radiation. Now, why is this important?
Allergies.
That's one reason for sure. But the other thing is there are surges of extinction every time one of these happens. And so the question is, why are there surges in extinction? And so there are 5 very serious things that happen to this planet when we get a magnetic pole shift. And 2 of them can be grouped. I mean, I know I'm doing the Spock thing right here, but it's 5 things and 2 of them get grouped. So let me explain what I mean. We're going to start with the ozone. The ozone that is up there right now, protecting us from the dangerous ultraviolet light. It's not the same ozone that was up there last year. And a year from now, it's not the same ozone. It's going to be up there. And what I mean by that is it's not the same particles. It's not the same molecules. There is this delicate balance. Sunlight creates ozone photochemically, photoionizes the particles, and it creates ozone. But the protons and electrons from the sun, those destroy ozone. And normally it's in a very delicate balance. The problem is, when Earth's magnetic shield weakens, it maybe lets in 0.5% more light. It lets in 60 to 200% more particles. That tips the balance, and the ozone starts to become eroded. Now this does 2 things. First, more ultraviolet light reaches the surface. That messes with the climate. Rapid climate change. There is a significant amount of the climate change we're experiencing on Earth right now that is because Earth's magnetic field has been weakening. It is letting in more of those particles. It is causing a thinning of the ozone, etc. That extra UV light is also not good for our skin. It's not good for animals' skin or their fur. It's not good for leaves. It's not good for insects. It's not good for microbes. It's not good for seeds. And so, right off the bat, just because of its impact on the ozone, you have a climatological and a radiological impact to the biosphere, life on Earth. But those particles that are coming in, because there's so many more of them, our atmosphere can't take care of them all. And those actually get all the way down to the surface much more often. These particles can also work clouds and lightning and pressure systems and ocean currents, and it's direct particle radiation, the same reason why you wouldn't want to be 2 feet away from Chernobyl when it blew. So you've got another climatological and radiological impact. Just from the fact that the magnetic field is weakening, you have a double dose of climate change and a double dose of extra space radiation. That is not the kind of thing that is good for life on this planet.
But as that is happening, don't forget the magnetic poles are shifting, and it is not just migratory birds that use this for navigation. An array of mammals, fish, marine creatures, turtles, sharks, whales, insects, triggers for plants to start growing seeds, start flowering, germination. So many things can be impacted by Earth's magnetic field. And so when it's not just migratory birds, it's things in the ocean, it's mammals, it is birds, it's insects. Things don't know where to go, and it's not just for migration. It's for foraging. It's for finding reproductive zones. Salmon swimming upstream, whales. So you've got a double dose of climatological impact. You've got a double dose of space radiation, while different rungs up and down the food chain don't know where to go for very critical things. They don't know where to go look for food. They don't know where to go reproduce. And if they're supposed to migrate, they don't know where they're going because they're supposed to be using Earth's magnetic field. And so you combine all of those things together and you realize, oh, that explains why there seem to be surges of extinction during these events. Now, the next logical question might be, what do I mean by a surge in extinction? So, there are literally millions and millions of species on this planet. And one or two go extinct every couple of days, weeks, it's a normal thing. For the most part, we don't know about it. There's evidence where it becomes, okay, maybe that's 20, maybe that's 100 species. Does that put a dent overall in the number of species on this planet? No, not really. But when you can look back and you can see, hey, wait a minute, at this exact same time where you have these magnetic events, you also have this surge in extinction. It starts to say, okay, how long do we have until this happens again? And something you brought up is number 6. It's a new problem that we've invented for ourselves.
Right.
So humans have gone through this many, many times, and we've managed to make it. We are a pretty spectacular species. But the problem is now we are electrodependent. Whether it's water sanitation or water distribution through pipes, global agriculture, transportation, various kinds of infrastructure, whether that's the internet, refrigeration to keep food fresh, heating in the wintertime, 911, hospitals, the entire power grid, things like that. All of these things require electricity. And unfortunately, the big risk to our species is the fact that this is going to take out the global power grids. This is the main worry about the sun altogether. If we were to get a massive solar flare, it could literally cook the entire world's grids in just a few hours. And there have been several studies on this, and some of the more important ones, including ones that were referenced in the government reports, our government reports. If we were to lose power on Earth, 90% of our species would probably be gone in 6 months. That's not nothing.
Right.
That's very, very significant. And maybe less time. I think that the argument could be made. And the more populated a region, the faster it would tear itself apart.
Right.
And so that's what we're looking at here. That's the score. That's what we are in the beginning processes of now. And you know how I said that throughout the atmosphere, whether it's the top of the atmosphere, whether it's clouds, all the way down here, you see the signs. We are also seeing the signs biologically. The number of unusual mortality events identified by our government just keeps going up. The number of unusual migration events keeps going up. Whale beachings keep going up. Sharks being seen in places they're not supposed to be seen. More and more and more. And I would actually argue that we're seeing this in humans as well. And here's why. There have been a lot of studies in terms of radiological impact on humans for obvious reasons. And a lot of them are applicable to what's happening here. The two parts of the brain that are most impacted by this event, when we have more particle radiation coming in, are the hippocampus right here, and then the locus coeruleus at the dead center of your brain. The first thing that happens is it starts to degrade the mitochondrial activity in your hippocampus. After all, we're talking about electromagnetic radiation. What are mitochondria? Those are the energy factories of your cells. They're using electrolytes along ion channels, and you start to lose energy in your hippocampus. Cognition goes down. Fun way of saying you get a little dumber. At the same time, it overexcites the locus coeruleus at the center of your brain, which is how your brain reacts to